Jai Jinendra, Namaste and welcome to my channel. Today we are going to solve the 106th question of the problem solving series and the 16th question of the topic tree. The difficulty level for this question is medium and this question has been asked in Microsoft, Amazon, Oracle, Google, Meta, LinkedIn, and this question was asked to me in Oracle in my last interview, and currently I am working at Oracle, as you know. Lowest common ancestor of a binary search tree. So we are given a binary search tree and we need to find the lowest common ancestors and we are given two nodes P and Q. So we need to find the lowest common ancestor of P and Q. What do you mean by lowest common ancestor? That means the lowest descendant of P and Q. That means like here when we are given 2 and 8, so descendant the origin, the closest origin, right? Like me and my brother's lowest common ancestor is my father, right? So that way. So for example here, from 6, 2 and 8 have originated. Okay, so the lowest common ancestor is 6. If like for example here 3 and 7. Okay, so for 3 and 7, we see the father of 3 and 7, that means the root of 3 and 7 are different. For 7 it's 8, for 3 it's 4. Okay, now the ancestor has to be the same. So who would be the closest ancestor? The closest ancestor would be 6, because for 4's root is 2. It has been derived from 2. But for 2 and 8 it has been derived from 6. So 6 would be the lowest common ancestor of 3 and 7, right? For example, if we take the example here, 0 and 4. For 0 and 4 the lowest common ancestor won't be 6. 6 would be the highest common ancestor. It is the root. Everyone has been originated from it. But for 0 and 4, the lowest common ancestor would be 2. Okay. Similarly, for 2 and 8 here, the lowest common ancestor would be 6. So we will return 6. Okay, the root of this, we will return the root. Here, when the lowest common ancestor is given 8 and 9, so what would be the lowest common ancestor of 8 and 9? What would be the lowest common ancestor of me and my son? I would be the lowest common ancestor. Okay. So lowest common ancestor of two nodes can be the node itself. It's given in the question. So for this, 9 has been originated from 8. Okay, so the lowest common ancestor will be 8. Now how do we solve this? So if you see a pattern, we have a property in BST, right? The right subtree will always be greater than the root. The left subtree will always be less than the root, right? So when we need to find the lowest common ancestor between two nodes that are given, P equal to 2 and Q equal to 8. That means the number from which it would originate, right? So what should it be greater than both the values? If it would have been greater than both the values 2 and 8, right? So in that case, both of these has to be towards its left, right? So but if it is both of them are towards its left, then how would they have been originated from the same thing, right? So for them to be originated from the same thing, one of them has to be to the left, one of them has to be to the right? So the lowest common ancestor should be greater than one of the value. Okay, so here P is 2, Q is 8, here we know that P is less than Q. What if P was 8 and Q equal to 2? So what we will do, we will make sure that P is always greater than Q. Okay, when we are given like this, so we will make sure that the P's value is always less than the Q's value. Okay, now we have P equal to 2, Q equal to 8. Now we see that, okay, if the value, whatever value will start from the root, if that value is greater than P and smaller than Q, that means it is the origin. For they have divided, right? The left part has divided, it has gone to the smaller part, the right has divided, and when we get a middle value, that is the origin, common ancestor, lowest common ancestor. Okay, so in this case, we see when we go to the 6 is greater than 2 and less than 8. So 6 is our answer. Now here when P is equal to 8 and Q equal to 9. Now you see that 6 is less than P as well. Okay, P, we see that the properties when we are getting is correct. P is less than Q, 8 is less than 9. Now P and 8 and 9, both are actually greater than 6. 6 is less than both P and Q. In that case, what do we want? we want the number to be greater than p, right? At least it has to be greater than the smaller value and has to be less than the larger value. Since it is small than p, we should go to the right. Now we went to the right. Now 8 we have got. Okay, 8 is actually equal to one of the value. So when we see that, okay, if it is equal to one of the value, that means what does this mean? Since it is equal to one of the value, we have got one value here. That means that would be the origin, right? Because like me and my son, the origin would be me. So if we have got one of the value, that means the other value would have been originated from it, because then only they have come, right? So we have got, if one of them is equal to 8, that means 8 is our answer, right? So we'll return 8. Okay, I think you have understood it. So we'll just code it. I've told the approach. So what we want first? We want that p has to be always less than q. So we give if p value is greater than q value, then we will interchange them. Okay, what we will do? We will make a 3 nodes trick temp. We will take equal to p. We will make, okay, and p we will make equal to q, and q we will make equal to temp. Now with this, p is always less than q. Okay. Else if we find that root value p value, okay, root value is if it is greater than p value, and root value is less than q value, or even it is equal to, okay, when they are equal also, that also, like 8 and 9, they were, p value was equal to this, right, and it is less than q, right? So if it is equal to this and it is less than q, because p is always less than q, so we can say that this is our ancestor node. So we will return root. Else if, okay, so this won't be if, okay, because this condition can come and again this condition can come. So don't give else if. Now else if, for this if, else if root value, we see that it is greater than p value. Okay, right? Now one thing, this is there, we have to travel to the bottom. We are not using either we can use recursion, or we could have iterated it also. Here I am using recursion. If root value is greater than p value, then what we will do? We will return LCA. Since the value is greater than the p value, but instead of greater than, we can say that if it is greater than the if it is less than p value, okay. If this is value, if the root here 8 and 9, the root value was less than p. If it is less than p, that means it is obviously less than q, right? So just we need to write this condition. If it is less than p value, then what we want to give? We want our root to become bigger and come between 8 and 9, right? So we will move LCA root right. We will pass root right, and then we will give p comma q. Okay. So this value would go and give us recursively it would go and give us the answer. We can believe in the faith of recursion. Now else what would be the condition left if the root value is greater than p value, q value, right? If it is greater than the q value, it obviously means that it is greater than the p value, right? So you can write the condition, otherwise you can directly just, let's write the condition just for the better understanding. Else if root value equal is here also we need to write if root equal to null, return null, okay. And here else root value is greater than q value, then what do we want? We want return LCA root left, we will go We want to reduce the value and then PQ. Okay, and this will give us our answer. The time complexity would obviously be order of log n because will be always traveling in the one direction. Okay, should I try run this? Yes, let's try run this example for say 8 and 9 we have done, right? So yeah, let's try run it for say 0 and 4. If P is 0 and Q is 4, okay, then what would be our answer? The answer would be 2. How do we come to this answer? Okay, now we see 0 and 4. We have root as 6. 6 is greater than this, right? 4. Sorry, 2 and 6 is greater than 2 and 6 is greater than 4, right? So it comes under this condition that root value is greater than Q value. Also, we see that P equal to where was the condition that I wrote? This one, P equal to 0 equal to Q equal to 4. It satisfies this condition, right? 0 is less than 4. So and it is the root value is greater than both of them, so it would come under here and will move towards the left. Okay, so now we are here and our numbers are 0 and 4. So 2 comes between 0 and 4, right? So this condition will be satisfied and will return root, that is 2. Okay. The link to the question is given in the description. Please try it yourself and then come to my code walkthrough section. Here is the code walkthrough of the 106th question in the lead code platform, lowest common ancestor of a binary search tree. You can see the companies that have asked these questions are this. A lot of companies have asked this question. And yeah, we can look at the code. It's same as what I have discussed. If P value is greater than Q value, we interchange it. And we have this condition greater than equal to Q P value and less than equal to Q. And we can directly write this else and do this because we know. And this would be the condition that if root value is, here we have interchanged the condition. So this is same, you will understand this. So we'll just submit this. So it has passed and I hope you have understood this question. See you all soon in the next video where I'll be explaining the 107th question of the problem solving series and the 17th question of the topic tree. Jai Jinendra.